So in this video, we're going to briefly discuss this subsidy question from an old midterm. So the question reads, suppose instead of taxing a product, the government decided to put a subsidy on selling the product, i.e. the government pays the seller T dollars, so $2, $5, whatever you think, each time they sell a unit. What would happen to market efficiency? Do not use the equations above to solve for exact numbers, since there was some equations in the previous parts of this question. Simply draw and label a market where there's a subsidy of $2, labeling all areas related to economic efficiency. Okay, so this is a little bit different than what we've seen in class. It kind of takes what we did in class and goes a little bit further. So this is kind of a harder question from an old midterm. All right, so let's just scroll down here and give us some room. So let's just start by thinking about this problem. So we have price and quantity. We have this supply curve, we have a downward sloping demand curve, and we have this equilibrium quantity and equilibrium price before this, subsidy comes in. So it's a subsidy of $T, example, $2. Hopefully that's still on your screen. Maybe I'll put it down here. $2, for example. On sellers. So every time they sell, they get $2. So what this is going to do is going to shift the supply curve down by $T. So to be willing to sell the same amount as they were before, they can actually accept $2 less or $T less because the government's giving them this $T every time they sell it. So this is the opposite of taxes, where we saw, a tax on selling the product kind of lifted vertically, like the supply curve by, $2 or $T. Now it's going down. So let's draw this new supply curve. We'll label it S prime, and I know it's not perfectly drawn, but the vertical distance between these two supply curves is exactly that subsidy. And so now what's happening is you walk into the store, find out where your new supply curve intersects your old demand curve, and this is how much you pay for the product. So you walk in, that's how much you give for the product, and that is PB. So if you're a buyer of this product, you walk in and you have to pay that much to whoever's selling the product. And then what happens is the seller gets that money that you gave to them, plus they get this T, for example, $2 from the government as a subsidy. And so that's going to be PS is PB plus tax. So notice this is a little bit different than the tax, but the logic and the thought process is the same. And so, just like we had a tax wedge, we can think of a subsidy wedge. So let's go back to red to talk about the quantity. So this is quantity, subsidy or Q sub or whatever you want to call it. Let's be a little bit better. So Q sub is like the new equilibrium quantity with this subsidy. So right away, what we should see is Q sub, this is supposed to be a Q, is above the competitive market equilibrium. And with the assumptions we've been making, this means that Q sub is going to be inefficient because we have no kind of externalities or anything like that right now. So we're going to get some kind of inefficiency here because we're not at Q star. We're not this blue Q star. We're above it, and that's going to be inefficient. Okay, so to think about efficiency now, what we're going to do is we're going to take this graph, we're going to draw it a couple times, and just apply our thought process to how we've been calculating consumer and producer surplus before, and kind of think about tax revenues a bit different because it's not tax revenue now the government's paying this much. And so we're going to put all those together and kind of talk about efficiency. Okay, so I'm just going to scroll down here and we'll come back up at the end when we kind of draw this inefficiency. All right, so I'm going to go back to blue. And let's first think about consumer surplus. So remember, it's below, let's write this down, below demand, or the demand curve, and above the price buyers pay, which here is PB, and only counts on exchanged goods. So we can only kind of go, horizontally up to how many goods are exchanged, which was Q star originally, and now is Q sub. Okay, so I'm just going to quickly redraw a version of that graph above. So we have the supply curve, we have the demand curve. We figured out that there is this subsidy wedge. The top was the price the sellers got. The bottom was the price the buyers paid. Okay. This was the new Q subsidy. And let's make sure we label the old equilibrium. So this is Q star and this is P star. So I'm not drawing the actual shift in the supply curve because we know it just creates this subsidy wedge. Whoever's getting more of the subsidy is going to depend on relative elasticities, just like we saw before. Okay, so let's think about consumer surplus, and let's do it in orange. So it's below the demand curve and above the price the buyers pay, but it only counts on exchanged goods. So it's going to be this big triangle here. So remember, PB is the price the buyers pay, so everything above that point, so it has to be above PB. We can only go to the top of our demand curve, and we get to go all the way out to Q sub. So this is the consumer surplus. So to consumer surplus, we need to add producer surplus. So producer surplus is going to be above the supply curve and below the price that sellers get, which is PS in this case. Okay, so I'm just going to scroll down again. We have price, we have quantity. Here's our supply curve, our demand curve, our old equilibrium quantity, our old equilibrium price. Then we had this subsidy wedge, this new idea of a subsidy wedge between buyers and sellers. The bottom is PB, the top is PS, and we have Q subsidy exchanged on this market now. And so let's do this in, let's say, pink. And so it's above the supply curve, so here's our supply curve, so we need to stay above it. We can only go to Q sub, and it's below the price the sellers get. So it's this big triangle there. So now we have these two overlapping, I'm just going to scroll out a bit, two overlapping triangles for our consumer surplus and our producer surplus. So remember, when we had taxes, we had this idea that tax revenue is going to be it's going to be efficient. We don't think of that as an inefficiency in the market. But if that's true, we should also think about spending. And here, the government's spending money on the good and essentially just transferring it to these consumer and producer surplus, plus a little amount that we're going to talk about less. So let's think about how much the government is spending in this scenario. So that's the next kind of area we're going to draw. So I'm just going to scroll down here. Maybe I'll zoom in just a little bit more. Hopefully that wasn't traumatic for you. Let's go back to hopefully the same color blue as we did before. And so let's think of government spending. So this is the same kind of idea as government revenue, but it's reversed. Like instead of the government receiving this much in income, this is how much they're spending. And so the spending is actually going to be, I don't know, GS, government spending, however you want to call it, is going to be equal to, let's just write it out in words, the size of subsidy, so the size of the subsidy times how many of the good are sold. Good sold. So in this case, that's going to equal, the size of the subsidy is T dollars, $2 or whatever, this question just left it very general, times Q sub, since this is the amount that we've decided is exchanged on the market. I'll just use that graph above to remind you. So what does this look like on the graph that we've drawn? So again, I'm going to draw a really similar graph that I've been drawing. Supply, demand, we have the old quantity and price. We had this subsidy wedge, which determined Q sub as well as PB and PS. And so let's think about this graph and think about what area relates to this government spending. Well, remember, the size of this wedge equals the subsidy. So that's the the width of this of the subsidy, and the length of the subsidy, or how many times we're paying this subsidy, is this Q sub. So that relates to this big rectangle right there. That area of that rectangle is exactly equal to T dollars times Q sub. Okay, so now we're going to put this all together. And what we're going to think about is that, let's go back to blue for this, economic surplus, or total surplus. We've been using these kind of terms interchangeably. In this case, is going to equal consumer surplus plus producer surplus plus tax revenue. In this case, this is negative because it's government spending. So in essence, what we're doing is consumer surplus plus producer surplus minus government spending that we just calculated. So graphically, the areas that we're adding up and subtracting are the following. I'm just going to scroll up here. We're going to add this orange triangle from consumer surplus plus this purple triangle, or pink I should say, triangle for producer surplus, and then we're subtracting this government spending since it's like a negative government revenue, right? So the first triangle plus the second triangle minus this third triangle, well, what do we have left over? I'm going to scroll right back up to the top. Usually been doing it in brown. The space that's left over is this little area here. So this is the deadweight loss. This is that loss of efficiency. And we should know that we're having this loss of efficiency, just to repeat myself again, is because we're assuming kind of competitive markets right now. So everything's working out really well for us. There's no reason for the government to be involved when we're assuming these competitive markets, even though in reality they might not exist that often. So anytime when we've assumed these competitive markets and we're away from this equilibrium P star and Q star, and particularly if we're away from Q star, we're going to get an inefficiency. So even though the inefficiency is now to the right of our equilibrium, it's still an inefficiency.